Hello, today we start with the parallax method. This method is used to determine the distance of the nearby stars. Nearby star means a star which is situated at a distance of 100 light years. So let us first discuss the parallax method. It is a change in the position of an object with respect to the surroundings when viewed from two different positions. Distance between two observation points is called basis. To understand parallax, hold pen in one hand and look at the pen first by left eye closing the right eye and then by right eye closing left eye. You will observe that position of pen changes with respect to the background and it is called parallax. Distance between two eyes is basis and angle AOB is a parallactic angle. This is an object which is viewed first from the left eye closing right eye and then from right eye closing left eye. The distance between the observation point is called basis and the angle AOB is called parallactic angle. If we consider OA and OB as the radius of circle and the distance x as an arc of the circle, then we have theta equals to x upon r. That is r equals to x upon theta. If the value of basis and the parallactic angle is known, we can find out the distance. This method is used to find the distance of the moon from the earth. Let us see how we use it to find the distance of moon from earth. Choose two distant points on the surface of earth as bases. Let these points are P1 and P2. For observation, choose a distant star. Let this is the line which is coming from the star to have simultaneous observation of the moon. Let the angle between the distant star and the moon from 2 points on the earth is theta 1 and theta 2. So theta is equal to theta 1 plus theta 2 parallactic angles, and using the relation r equals to x upon theta and theta is theta 1 plus theta 2, knowing the value of basis that is x, parallactic angle that is theta, one can find out the distance of the moon from the earth. The size of molecule. Size of molecule is very small, so we estimate this size by using a method which is called oleic acid method. It is a method for finding the size of a molecule of a liquid in which a layer of 1 molecule thickness on water is prepared. First, make a solution of 1 by 500 concentration of oleic acid in alcohol. Take n drops of this solution on a water surface in a container and wait for some time so that alcohol gets evaporated and thin film of oleic acid is formed on surface of water. Area of this film can be found out using a trace paper and graph paper. Let it be A and T is the thickness of the film. Therefore, the volume of the film is equal to A into T. If V is volume of each drop, then volume of n drops is equal to V into N. Volume of oleic acid in n drops is equal to Nv upon 500. From the equation 1 and 2, A into T equals to Nv upon 500. T equals to Nv upon 500 A. If the thickness of film is size of a molecule, then T gives the size of molecule and we are able to estimate the molecule's size. The units which are used for measuring the small lengths. First is 1 angstrom, and 1 angstrom is equal to 10 to the power minus 10 meter. And 1 angstrom is represented in this way. It is a symbol of angstrom. Angstrom unit is generally used to express the size of the atoms or wavelengths. If the wavelength is said to be a 7000 angstrom, then it means 7000 into 10 to the power minus 10 meter. That is equal to 7 into 10 to the power minus 7 meter. The second unit which is commonly used to measure the small distances is a Fermi meter, and 1 Fermi is approximately the size of nucleus. The units which are used for measuring the large length, number 1 is a astronomical unit. Astronomical unit is defined as the average distance of the Earth from the Sun. It is the Sun and it is the Earth. This distance, average distance between the Earth and the Sun, is equal to 1 astronomical unit. And 1 astronomical unit is equal to 1.5 into 10 to the power 11 meter. The second unit which is used for measuring the length is a light year. 1 light year is the distance traveled by the light in vacuum in 1 year. Using the relation d is equal to v into t. Here v is a velocity of light and t is a time of 1 year in second. When we multiply the two, what we get is a light year, and 1 light year is 9.5 into 10 to the power 15 meter. Remember, light year is a unit of distance. It is not the unit of time. Once again, light year is the unit of distance, not the unit of time, and 1 light year equals to 9.5 into 10 to the power 15 meter approximately. Our nearest star is the Alpha Centauri and it is 4.2 light years away from us. It means the light coming out from Alpha Centauri reaches to the Earth in 4.2 years. The next unit for measuring the large length is a parsec. Parsec is defined as the distance at which an arc of 1 astronomical unit subtends an angle of 1 second. Say it is an arc of 1 astronomical unit. And the point where it subtends the angle of 1 second, that distance is equal to the 1 parsec. 1 parsec equals to 3.1 into 10 to the power 16 meter. Parsec is the largest unit of distance and it is commonly used in astronomy.